Alrighty, hello friends. It is Wednesday, and today we are going to be working on the article Reasons for Seasons. You should have a paper copy of this. If you have a pen or a colored pen or a pencil or a highlighter of some sort, you might want that out because we are going to be annotating today. So, when you read, it is super important that you annotate and highlight and underline and circle and take notes in the margin to help you identify important pieces of information in the article and to help you have a place to go back to look at information. Maybe if you are writing a CER response to the article, or if you're answering questions about the article. So it's super important to learn how to properly annotate for not only this class for science, but it's also going to be helpful in social studies and possibly math when you're annotating problems that you like word problems, or in ELA class when you are reading an article in that class. So annotating is super important. So we're going to work through this Reasons for Seasons article together and annotate and highlight. I'm using the Kami extension, but you all have it on paper, so just bear with me. I probably won't write in the margins a whole lot because it's kind of wonky. So, reasons for seasons. Like all the planets in our solar system, Earth orbits around the sun. I think that is important because we need to remember that Earth orbits around the sun. Earth also rotates on its axis, which is currently tilted 23.5 degrees to the plane of its orbit. Rotates on its axis, which is tilted 23.5 degrees. Oh, don't want to do that. While the tilt of Earth's axis will change very little over your lifetime, the part of Earth that is exposed to the most solar energy from the sun, does change, and on a regular basis. This is because the tilted Earth orbits the sun. All right, I think those are important pieces of information. So that first paragraph is talking about how the Earth is tilted at 23.5 degrees, and different parts of the Earth are going to experience different amounts of solar energy due to that tilt, due to that rotation while it's revolving around the sun. What do you think causes the seasons? Many people believe that seasons depend on the distance between Earth and the sun. That might seem logical, but consider this. Earth travels in an ellipse or oval around the sun. I'm going to go ahead and highlight that because it's something that we've talked about before, and I want to make sure that we all remember that. Due to this ellipse, Earth is slightly closer to the sun in December than in June. If the distance from the sun were responsible for how warm Earth is, it would mean that everyone on Earth would have summer in December. You know this is not true if you live in the northern hemisphere. So right there, they're explaining that there is this misconception, this idea that the distance between Earth and the sun causes seasons, but that's not really the case. Earth's atmosphere and the tilt of its axis are responsible for changes in seasons. There is a big piece of information. Earth's atmosphere and the tilt of its axis are responsible for changes in seasons. These factors affect the amount of solar energy that reaches each part of the Earth at any time. The tilt of Earth on its axis affects the angle at which the sun rays pass through the atmosphere and strike Earth's surface. The higher the sun's angle, the more intense the solar radiation. I'm going to highlight that because I believe that's a focus area question. All right. Again, it says the higher the sun's angle, the more intense the solar radiation. The less atmosphere the rays must pass through. The lower the sun's angle, the less intense the solar radiation, and the more atmosphere the rays must pass through. What do you notice about the difference in the circles of light in the pictures above? So here we have winter, and the sun is the sun is closer. We have summer, the sun is further away. The tilt of Earth also affects the length of daylight in any particular area. Between March 21st and September 21st, on average, the northern hemisphere tilts towards the sun. Let's highlight that. Between March 21st and September 21st, on average, the northern hemisphere tilts towards the sun. During this period, the surface of Earth in the northern hemisphere receives longer periods of daylight than the surface of Earth in the southern hemisphere. More direct sunlight for longer periods causes warmer weather. So that would kind of explain why we have summer. So we have longer periods of daylight. However, between September 21st and March 21st, the southern hemisphere tilts towards the sun and has warmer weather. So that's the southern hemisphere. I don't want to highlight that. On December 21st or December 22nd, depending on the year, the southern hemisphere celebrates the first day of summer called the summer solstice. On that same day, the northern hemisphere experiences its first day of winter. So I'm going to highlight that. The northern hemisphere experiences its first day of winter, the winter solstice. And that's in the northern hemisphere. On 2 days of the year, somewhere around March 21st and September 21st, the sun is over Earth's equator and neither hemisphere tilts toward the sun. On those 2 days, the surface of Earth in both hemispheres receives equal amounts of energy from the sun. Night and day are almost equal in length all over the world except the poles. These 2 days are called the equinox. To remember this term, think of equal night. Equinoxes occur midway between the solstices. So I'm going to go ahead and highlight somewhere around March 21st and September 21st. Sun is over Earth's equator. Okay. Let's see here. These 2 days are called the equinox. To remember this, think of the term equal night. All right. On average, December 21st has the shortest period of daylight in the northern hemisphere. But December 21st is not usually the coldest day of the year because it takes several weeks in fall and early winter before the atmosphere and oceans cool off. There is a lag or delay in seasonal temperatures, and the coldest period in the northern hemisphere, therefore, may not arrive until early February. And we know this to be true because we know that the end of January into February and sometimes March is really, really cold for us and really snowy. The same seasonal temperature delay occurs in spring and summer. Just as soon as March 21st hit doesn't mean that it's summertime, that it's the days are warm and all that good stuff, okay? It takes some time. The amount of solar energy that reaches each hemisphere affects the temperature of Earth's surface. I'm going to highlight that. The amount of solar energy that reaches each hemisphere affects the temperature of Earth's surface. Even though the sun is closer to the Earth in winter than in summer in the northern hemisphere, the sun's rays do not hit Earth directly. I'm going to highlight that. The rays hit at an angle after passing through the atmosphere. During winter, there are also fewer hours of daylight, which accounts for some of the chilly winter. Seasons on other planets. Did you know that other planets also have different seasons? The spin axis of Uranus, for example, points to the sun. That means that Uranus is tilted about 98 degrees to the plane of the ecliptic, the plane along which the sun exists. Compared to Earth's current tilt of 23.5 degrees, with Uranus completely on its side, one hemisphere always has summer during half of Uranus's 84-year orbit. This pattern creates 42-year seasons of warm and cold on each end of Uranus. Other planets also have interesting relationships to the sun that cause different seasonal characteristics. So now that we've read and we've highlighted this information on this article, you're going to be able to use this and go into Summit Learning, and you're going to go to the Seasons checkpoint. You're going to go to your year view, go to Science, click Scale Visualizations Project, go to Checkpoint for Seasons, and you're going to click that. Sorry, my dogs are scratching, being weird. And on slide 4, when finished reading, answer the following questions linked here. You're going to click into this Google form, And you are going to answer these 3 questions, and hopefully your highlighted information on your article will help you easily answer these questions. All right, guys, if you finish early before class is over, you are going to be working on SDL time. So that's making sure that your projects in science are all caught up, that any overdue checkpoints are caught up. You're going to be making sure that power focus areas and additional focus areas are caught up. And hopefully, I will see you all tomorrow. Have a wonderful Wednesday.